Hi, today we are going to solve a really quite famous problem, that is longest common subsequence. So we need to find the subsequence which is common between these two strings, and it should be the longest among them. Let's first see that what is a subsequence. Suppose we have A, B, C, D, right? So the subsequences could be A, AB, A, C, A, D, anything, right? But the subsequence is any sequence of this string. It could be ABC, ABD, AC, BD. But what is the thing here is it could be contagious, but it might not be contagious, because here AB is contagious, right? But AC is not contagious. But the thing here, it should be that the the order should be maintained, right? A should be before B, B should be before C, like that. So the order should be maintained, and the subsequences could be. So if we calculate the subsequences of A, B, C, right? So the subsequences could be A, AB, AC, B, BC, C, right? So among these two strings, we need to calculate the longest common subsequence. So here we can see that the longest common subsequences between these two could be A, D, B, right? A, D, B, and here also we have A, D, B. But another subsequences which could be long is let's see, D, C, B could also be the longest subsequences, because D, C, B present here, D, C, B also present. So we don't need to return the longest subsequence, we just need to return the length. So the length here is 3, right? So how could we do this? The first approach could be we calculate every subsequence of this string and every subsequence of this string. It could be A, D, C. A is a subsequence, A subsequence, D subsequence, C subsequence, AD, CB, ADB, C, BC, and the subsequences here could be D, A, B, D, C, AB, AD. So we can calculate each subsequence from this string and every subsequence of this string, and then compare every subsequence with the subsequences of another string. So here could be there are the total number of subsequences this string can have is 1, 2, 3, 4, 5. So 2 to the power 5 subsequences this could have, and this could also have 2 to the power 5 subsequences. So we would need total time of 2 to the power 5 into 2 to the power 5. We need total this much calculations. So here, if the length is m and here length is n, then the total time complexity of this algorithm would be 2 to the power m into 2 to the power n. So this would be an exponential time complexity. So we should reduce this. So let us not just calculate every subsequence of first string and every subsequence of second string, but what we should do is we just think of calculating the length of subsequence along. Means let's have a smaller subsequence or smaller string, that is A C D, and another string could be A E D, right? So let's think of uh, calculating the longest common subsequences of these two strings. Here we can just see that AD would be the longest subsequence, that is with length 2, right? But how we are going to do it programmatically? Suppose we are standing at their last position. Okay, so let us compare them character wise. Okay, so what here we can see is D and D are same. Okay, so here we found that we can have a subsequence of length 1 which is common between them. So we just can go ahead, like we can go ahead with both pointers. We can shift both pointers. Now we can see that C and E are not equal, so it would not contribute in our longest common subsequence. So we can shift both the pointers here. But here is something we are missing. Let us see. Let us see A, C and A, E. What is the thing we are missing here? Currently these are AC and AE, but let us suppose it would be EC and AE, right? So these this C and E are not equal, so we are shifting our pointers. But what we are missing here is, now we are comparing E and A, and we will shift here, so we will not get anything common. But let us see, suppose what if we have shifted only a single pointer? We have E, C and AE. First we were here, and suppose we have shifted only a single pointer of this side. So what it would be, EC pointer would be here and AE pointer would be here. Now we can compare these E and E, right? So here we found a length, that is 1, that is common between these strings, right? And another thing we can do here is, we don't shift this pointer, we shift this pointer. Okay, so E, C, here this pointer is here only, and we shift this pointer, second pointer, so A, E, but we don't find anything. It's okay. So in case where we found the characters are same, we can shift both the pointers. But in case where, let's write it first case. What is the first case? Character is equal to the another character, C1 equal to C2. In this case, shift both pointers. In the case C1 is not equal to C2. In this case, shift one pointer at a time. Okay, so we can solve this problem. How we can solve? Let us see. Okay. Suppose we have a string. Let's take the previous string A, C, D, and another string A, E, D. Now their indexes could be 0, 1, 2, 0, 1, 2, and we are having two pointers, right? One is here, one is here. So what we can see that for this solution we are expressing both the strings in terms of indexes, right? So the solution function could be expressed in terms of a function with the index 1 with the index of first string and the index 2 with the index of second string, right? So what does this signify? That this function signifies that this function will calculate the longest common subsequences for the string 1 up to index 1 0 to index 1 in the string 1 and 0 to index 2 up to string 2 into string 2, right? So here we can see that 0 to 2 and 0 to 2 in index in string 2 we are calculating the longest common subsequence. So this is f of 2 and 2. Now in this case the characters are same. So what we can do is we got a length 1 of subsequence which is common, and what we are doing is shifting our pointers, shifting our indexes. So here it would be 1, here it would be 1. So it would be f of 1 comma 1, right? And now this A, this C and this E are not equal. So what we can do is we can explore two possibilities, that we shift one pointer at a time. Suppose we shifted this pointer. So this would be f of 0 and 1. We shifted only this pointer, not this pointer. And the second exploration could be we shifted this pointer at 0. So it would be f of 1 and 0. So now in this case we are standing at 0 and 1. This 0 and this 1, right? So E and A are not equal. So let's shift first left pointer. So f minus 1 and 1. And another exploration could be f of should be 0 and decrement this should be 0, right? So what here minus 1 means this pointer is here. So the string is finished, so we don't have any more string which could be common, so it would return 0, right? And f of 0 0 means both are standing at 0, right? So these characters are equal, so this would return 1, it would be plus 1, and f of minus 1 minus 1. Now both the strings are vanished, so it would return 0, and it was plus 1, so it is returning 1, right? It is return 1, so this would return 1 and 1 and 1. So f of 1 1 returned 1 here from this side. Now explore this side, f of 1 and 0. So f of 1 means it is at this position and it is at this position. C and A, they are not equal, so we will explore two possibilities. Either shift first pointer, so it would be 0, and kept another as it is. Another could be f of 1 and minus 1. So what minus 1 means? The second string is vanished, so it would return 0. There is no other string left. And f of 0 0 means a, which also came here also, you can see that. So 0 0 would return 1, so this method would return 1. This also returned 1, this also returned 1. So we can take, if it would have returned 1 and this would have returned 0, we would have taken 1. So we explored both the possibilities and taken the best out of it, best possible solution, right? So that is we are going to do. So what we have done, first what we have done is expressed everything in terms of index. Like we have expressed both string s1 and s2 as index 1 and index 2, right? So that is we have done. And the second thing what we have done is we have explored possibilities. When we had no same string, same characters, like we had A and we had B, C, E here. What we had done is we explored both the possibilities. At a time, either this pointer is shifted or this pointer is shifted. First CA, so this pointer is shifted, and EB is same, and the second time we shifted the second pointer. So CA, this pointer is here itself, and we shifted EB, this pointer we have shifted, right? So explored all possibilities. And the third thing what we have done is we have taken the best possible answer. Here what we can see is, here if it would be 1 and it would be 0, then we would be taking the maximum of it. So we are taking the best possible solution here. Okay. In this case, we can see that we are exploring every possibilities. Like we are shifting one pointer at a time in case where the character is not matching. So there would be overlapping sub problems. Like here we can see that we got f of 0 0 here and f of 0 0 here, right? So what we can do here is we can memoize the value of the previous calculation. Just like if we have calculated the f of 0 0 previously, we would not calculate it again. Means here what f of 0 0 returned is 1. So whenever we encounter f of 0 0 again, we will see that we have calculated f of 0 0 previously, so it would directly return 1. Means we would not explore f of -1 -1. After this we would just directly return 1. So how we would do this? We would just store f of 0 0 as 1. That is how we are going to do.